Hey everyone, welcome back to Dietitians and Nutrition Support. Sometimes when you're doing enteral nutrition calculations, it can feel a little bit confusing because there's so much math involved and maybe that makes it a little overwhelming for you. If you're feeling that struggle or maybe you just need more practice, today's cases will focus on specifically the calculations that are involved in making enteral nutrition recommendations. So we'll show you how to set up all of your equations, plug in the correct numbers, and get that recommendation outcome. So let's jump to the other screen and get started.
All right, so let's get started on our first example patient. Because we're just working on quick calculations today, I kept it pretty simple for us. Looking at patient needs, you're going to see this first patient falling somewhere between 2613 to 3135 in terms of kcals. We're only looking for protein goals here today. We're aiming for 125 grams of protein for this person, and we're looking for about 1 ml per kcal of water. We have a formula already selected for us to use, so all we're going to do today is figure out how much of this formula we need and what rate we're going to provide it at to this patient in order to meet those basic needs. And just to check out the formula that we have today, it looks like 1 liter of formula is going to provide 1,300 or so kcals, which means we're going to have a little more than 1 kcal per mil of this formula, 56 grams of protein, 40 grams of lipid, 160 grams of carb. We only need to meet 1,000 milliliters or 1 liter to be able to meet our recommended daily intake for micronutrients, and we get 820 milliliters of free water in that 1 liter of formula. So let's go ahead and set up all of our calculations that we're going to need for this patient. All right, so as you can see on the right-hand side, I have set us up for being able to just kind of drop numbers into these equations that are all built to be able to just easy crunch out all these calculations. Note that the way that I've written these, you can literally put any number into these multiplication spots. So really, your most important feature of this is going to be picking the correct numbers to put in each of the spots. Past that, don't stress out. This is basic multiplication and basic division, and you can totally handle it. So let's try and sort through all of the numbers that we already have provided to us and make sure that they go into the right blanks. So if we're going to start working through this, then let's just start at the very top with our aiming for a blank number of kcals. For this patient and for your patients, you're going to want to pick somewhere within their kcal needs range, and for this patient, we are at 2613 to 3135 kcals, and I decided today that I'm interested in using the number 2900. So if I'm interested in looking at how much volume of formula I'm going to be providing, I'm going to take my 2900 and I'm going to drop it right here at the beginning of both of these equations. You'll notice that both of these equations are very similar because this top one is looking at liters of formula and the bottom is looking at mils of formula. And so we already know that 1,000 milliliters go into 1 liter, so we can kind of interchange numbers here a little bit, and we'll come to the same outcome just with differing units. So from the information on the left-hand side, I already told you that 1 liter of formula is going to provide us with 1304 kcals, and so I know that if I'm looking for kcals per liter, that number is going to go right there, that 1304. But if I was looking for this unit of kcals per mil, it's actually pretty easy to get that information, even though it's not technically on the left-hand side of our screen. I'm just going to divide my 1304 by the 1,000 mils that are in each liter, and I'm going to say 1.304 kcals are happening per mil of formula. If I do some quick division here, if I'm dividing my 2900 by 1304, that puts me at 2.2 liters. And then if I multiply that by 1,000 or do this math on the bottom, I can see that I get to 2,200 mils of formula. So now that I know how many mils or total liters that I want to provide to this person, I'm going to pick a feeding rate. For this particular patient, I'm going to go with 24, which is pretty classic for people who are being enterally fed, that they'll be fed all throughout the day. Now, typically when we're looking at feeding rate, we're often looking at number of mils per hour. If we use a liters per hour, we're going to end up with a decimal, and that's not always the prettiest thing, so we're just going to stick with mils per hour for now. Knowing that I need to get to a total number of 2,200 mils per day, that's going to be here on my numerator, and I know that I'm feeding over 24 hours, which means my denominator puts me here. Now, if you do this math with me, you'll note that this ends up being 91.6 meals per hour, which is not beautiful. So I can either round that up to 92 if that is something that I want to use, or you might be in a facility that likes to round to the nearest 5. So you might go to a 90 or to a 95, depending on your rounding or what your institution needs. But for this instance, I'm going to keep with 92. I like that number. And so we are going to stick with 92 mils per hour. And because I decided to x-nay my initial calculation value, this means that I'm actually not going to be giving exactly 2200 mils anymore, which means I'm going to go back and do a little extra calculating again. I'm going to say actually then I'm going to have 92 mils per hour, and I'm going to multiply that by my 24 hours, and that's going to give me a total of 2208 mils or 2.208 liters. So now I know we were just working with mils, but I actually like to go back to this value of liters for the rest of our calculations. And that's mostly because it is easier for me to do these calculations knowing that the formula provisions provided to us are based on a 1 liter of formula. So because I know that I'm going to have this 2.208 liters as a portion of all of my provisions, I'm actually going to just drop that in all of the first spots on each of these next set of equations. And the reason I'm going to do that is because I know I'm going to have that same amount of formula, and I'm just trying to figure out how much of each of these I'm going to be providing to my patient. So again, this is speed round. We made this super easy. We correlated each of our lines all the way across so that we should be able to just pop in those numbers and calculate all the way. So I'm going to go ahead and start popping those numbers in and doing my calculations, and you can do those at home on your own piece of paper. Okay, so obviously I did some quick math here, and hopefully you followed along with all that math as well. We already knew the number of liters. I popped in all those basic variables that we had from our formula, and then we got an outcome of all of the information that we have from our formula. That 2.208 liters is going to provide all of these goodies. Note that at this point, we actually still need 1 ml per kcal of water provided to this patient, and we are not going to be providing enough based on the kind of higher kcal content that we're providing than the fluid that is available within our formula. So note that for this, we could take our 2879, subtract 1810, and give ourselves a need of approximately 1100 mils of extra free water. If you want to break this down further, we could look at about 275 mils given Q6. But there's a lot of different options there that you could do with the extra free water flushes. Our last variable here is whether or not we're going to meet the RDIs for our micronutrients. We know that 1 liter of formula is going to meet them, and we are providing 2.208, so we know that we have met them. Give that a check, and look at, we were able to quickly calculate through all of the things that we're providing to this patient. So let's set up our second patient here, and we'll see how this works for each of our different enteral calc needs. All right, so you can see we have a new patient on the left and a new formula as well, but the same setup on the right-hand side. So let's use this to do some quick calculations and work through all of these to make an enteral recommendation. Falling somewhere within my kcal needs, I've decided to aim for 2000 kcals. You know that I'm going to drop that number right here in the first slot. And then we're looking at kcals per mil and kcals per liter. I know that 1 liter is going to provide 1526. And I just moved the decimal places over a couple to get to 1.526 for my kcals per mil instead. Quick division shows me that this is going to be 1.3 liters or 1300 mils. For this patient, we actually decided we're going to be feeding over 18 hours. So remember, you can put pretty much any numbers you want in here. You just want to make sure you put the right ones in the right spots. So if I know I'm looking at 18 hours and I know I have 1300 mils, this puts me at 72 mils per hour. But maybe today I want to change it up and go down to the nearest 5 instead of keeping it at 72. So I'm actually going to ditch this and I'm going to use 70 mils per hour, which means I have to change up my total formula provided, going for 70 mils per hour times 18 hours. It's going to put me at 1260 mLs. So I know that I can also make this into 1.26 liters by just dividing by 1,000, and of course I'm going to drop that in all of my first spaces here. Easy enough. So after I've dropped that value, then I can come over here to my formula pieces and I can put all of those values in as well. So again, I'm just going to do some quick math here and I'll let you do your math on your own sheet. So just like that, I've been able to provide all the kcals and all the protein that this patient needs. And looking at their last set of needs that we're trying to qualify today, we need 1 ml per kcal of fluid. So if I'm looking at 1922, subtract my 958, and that is going to give us needing an additional probably about 1,000 mLs of fluid per day. Again, lots of ways to provide this, but if you wanted to go Q6, you could do about 250 mils. Last piece of the puzzle here is whether or not we meet the RDIs, and we know that 1 liter of formula is going to meet them, and we are giving over a liter of formula, which means we can check that box as well. So hopefully that one seemed quick and painless. Let's do one more to make sure that we know exactly how to set up all of our equations and plop our numbers right in there so that we can quickly and efficiently figure out how much enteral formula our patient is going to need. Alrighty, so we're on to our third patient. You can see the new patient needs on the left-hand side and the new formula provided. But alas, the formula is different. So the last couple formulas, we've been looking at the total nutrient content for 1 liter or 1,000 milliliters of formula. But in this case, we actually have a patient who's going to be using cans of formula instead. So you see that a can of formula has 8 fluid ounces, which also equals 237 mils, which means if we are trying to estimate what we're going to provide to this patient, and maybe we're sending them home to do bolus feeds on their own, we are going to want to provide them a number of cans that they're going to consume throughout the day. But never fear, we can just slightly modify our calculations, and then we will be able to have them up and going with their new enteral recommendation in no time. As per usual, I'm aiming somewhere within their calorie needs, and today I am estimating at 1900 kcals as being my goal. So I know that I need 1900 kcals, but I'm not actually looking now anymore for a total number of liters. I'm going to be looking for a total number of cans. So instead of doing this liters, I'm just going to take that out and I'm going to say cans instead, knowing that I have information right here for the total number of kcals per can. So I can say that 285 kcals per can are going to be what's present, and I know I need 1900 kcals, and that's going to put me at a total of about 6.6 cans. So for this patient, if we're imagining a patient getting sent home with cans to be able to provide bolus feedings to themselves or have caregivers provide that for them, we want to make sure that this is pretty easy and simple for them to handle. And 6.6 is not a beautiful number to divide up and try and work with to make that happen. 3/5 of a can can be hard to estimate, so I like to estimate and maintain some level of cans that is either a whole can or a half can provision for our patients. In this case, you could round down and do 6.5 cans if you wanted, or you could round up and do 7 cans. So for this example, I'm going to go ahead and round up and do 7 cans. So as this patient is on bolus and we've already figured out the cans that they need, we don't need to worry about these next 3 lines, worrying about feeding rate and number of hours we're feeding. We are just skipping forward to total formula provided. So we know that we're given 7 cans, so really in terms of total formula provided, we are giving 7 cans. But if you want to know information about mils, you can take that 7 and multiply it by 237, and that'll give you 1659 total mils, or 1.659 liters. Now, if we look over at our formula, you can see that all of this information was based on one can. So that means that the first number that's going to go into our next set of equations is going to be the total number of cans that we're providing, and then we'll multiply it by all of this formula information to get the total number of nutrient provisions. So that means I'm taking my 7 cans and plopping that number right here in the first spot. And just like our last two examples, these all have lines straight across you can draw, and you can just put all of those next sets of numbers into these blanks. So as you can see, just as quick and easy as the last ones, multiplying the number of cans times the content of each can gives you the total number of nutrients we're providing. Looking at our water, that's the only patient need that we haven't met yet, being at 1330 and needing to get closer to about 2000. So we're going to estimate that we need about 600 more mils per day, provided somehow in flushes. So as we've alluded to previously, there are quite a few different ways you can do your free water flushes. Maybe one recommendation I might give is to sandwich your boluses, depending on how many boluses you have throughout the day, doing a free water flush, and then doing a bolus, and then doing another free water flush. So if you do 3 boluses throughout the day and you know you have a free water flush before and after, you could take this, divide it by 6, and then you do 100 ml flush prior to a bolus and after the bolus, and that would easily get you to your 600 mils per day. So lots of different options as to how you might do that, but depending on the schedule that you provide your bolus, you can help to plan that out with the patient. Our very last piece for this patient is looking as to see whether or not they're going to meet their RDIs for micronutrients, and we see that because we are providing over a liter of formula to this patient, we know we can check this box and say that yes, we are going to meet the RDIs. So that's it. That's 3 different patients with differing needs, mix and matching what numbers we're going to be providing throughout each of these calculation steps, but the setup can be essentially the same whether or not you're providing a continuous feed or a bolus feed. You just plop the numbers right in and you can work out the easy math. So no need to be frustrated or worried about these calculations. So long as you know where to put the numbers, you can certainly execute all of these enteral calculations pretty easily.
Thank you so much for joining us here today. If you have any comments or questions, don't forget to leave them in the comments boxes below, and we look forward to seeing you next time.